Welcome dear learners. We are continuing Inorganic Chemistry 1 and we are now starting Unit 3 of that course, Introduction to Nanomaterials. This module is intended to discuss Introduction to Nanoscience and Nanotechnology. That is, the module is Introduction to Nanoscience and Nanotechnology. In this module, we are going to deal with these concepts: definition of nanomaterials, nanoscience and nanotechnology, historical revolution of nanotechnology, Faraday's divided metal, Lyserg's cup and nanosystems in nature. First of all, the prefix nano. You all familiar with several prefixes like deci, centi, milli, micro, nano, pico, etc. Such prefix, in a similar way there is a prefix that is nano. What do you mean by the term nano? The prefix nano is actually derived from the Greek word. It represents dwarf. That is, nano is derived from the Greek word for dwarf. This is a dwarf. And actually 1 nanometer simply represents 1 billionth of a meter. What do you mean by 1 billion? 1 billion is simply 10 raised to 9. So 1 billionth of a meter is 1 nanometer. Then what will be the quantity corresponding to 1 nanometer? That is, from this it is clear that 1 nanometer is equal to 10 raised to minus 9 meter. That is, 1 nanometer is equal to 1 billionth of a meter. Now, you are very much familiar with so many other metric prefixes that I mentioned just earlier. And what are such metric prefixes? What is the purpose of using a metric prefix? If you are doing or some measurement, and if you wish to increase that quantity, and if you ascend that quantity, you can use increase matrix prefix, and you can also reduce that quantity by using reduce matrix prefix. The matrix prefix are like this: deci, centi, milli, micro, nano, pico, femto and atto. These are the quantities used to reduce a given quantity, and some other parameter, that is deca, hecto, kilo, mega, giga, tera, peta, exa, etc. These are used to represent bigger quantities. So, in general, we are using metric prefixes to represent some bigger quantities or some lower quantities. To represent the small quantities, we are using these metric prefixes, and for representing bigger quantities, we are using such metric prefixes. Now, our nano, that is 10 raised to minus 9, is appear on left hand side, and 1 nanometer equal to 10 raised to minus 9 meter. Now, definition of nanomaterials. We all heard about the term nanotechnology, nanomaterial science, etc. Now, we are entering into the definition of nanomaterials. How we can define a nanomaterial? The definition is here: a nanomaterial or nanomaterials are materials with at least one dimension of 100 nanometers or less. You know about 3 spatial dimensions, 3 Cartesian coordinates, namely x coordinate, y coordinate or z coordinate. They all are mutually perpendicular to each other as shown here. And for a material, in any one of these dimension, in any one of these axes, if the size is 100 nanometer or less, then you can call such a material as a nanomaterial. So, it is not necessary for a material to be 100 nanometer in all dimensions, and the definition says like this: for a material to be considered as a nanomaterial, its one dimension must be in the range of 100 nanometer at least. This is the definition of a nanomaterial. Now, what will be the actual size of a nanoparticle? We cannot see a nanoparticle with the help of our naked eye. Then, how to predict the approximate size of a nanoparticle? We can use a human hair for the comparison or to represent the approximate size of a nanomaterial. That is, we can compare the size of the nanomaterial with the size of human hair. And the question arises, how much thick is your hair? And this picture represents the fairy tale character Rapunzel, famous for her very long hair. And the question in front of you is, how much thick is your hair? The answer is here, normal hair diameter is 0.06 to 0.08 millimeter. And this value represents ultra thin hair, and this value represents thick hair. Suppose we can take an average. The average will be 0.07 millimeter. Thus, the average single hair diameter is here, that is 0.07 millimeter. 0.07 millimeter, when converted into meter, you will get 0.07 into 10 raised to minus 3 meter, or simply 7 into 10 raised to minus 5 meter. This is the average hair diameter. So, average hair diameter is fixed as 7 into 10 raised to minus 5 meter. Now, we can make a comparison of this hair with a nanoparticle. And we can take a nanoparticle with the size 7 nanometer for the comparison. Let the size of the nanoparticle is 10 raised to minus 9 into 7, that is 7 nanometer. We can take a calculation like this. Average diameter of hair divided by nanoparticle size. Average diameter of hair is here, that is 7 into 10 raised to minus 5 meter, divided by 7 nanoparticle, 7 nanometer sized nanoparticle, that is 7 into 10 raised to minus 9 meter. On dividing this, we will get a quantity that is equal to 10 raised to 4. What conclusion we can arrive from this calculation? We can say that the average diameter of hair divided by the nanoparticle of size 7 nanometer will be equal to 10 raised to 4. Thus, we can conclude that the size of a nanoparticle with 7 nanometer size is 1 by 10,000 to that of normal hair. That is the conclusion. Now, we are discussing another area, that is nothing but the properties of nanomaterials. The properties of matter, that is every matter, changes rapidly when considered it in the nano level. This simply implies that whenever we are taking a bulk material and it is reduced to nano level, the size is reduced to 10 raised to minus 9 meter level, its properties changes drastically. That means the physical and chemical properties of substances changes abnormally when changed it into the nano level. This is an important aspect associated with nanomaterials. Now, the nanomaterials have unusual physico-chemical properties. Let us have a look on what are such unusual properties. For example, the first one, opaque substance become transparent. You know the fact that copper metal will not transmit light. That is, copper is an opaque material. But when you take nano copper, it will be 100% transparent. That means opaque substance will be converted to transparent substance. Another example is here, solid turns into liquid at room temperature. You know the fact that your gold ornament is a solid at room temperature. You can convert it into nano level. When you are taking nano level, it is a liquid at room temperature. Now, next case is about the silicon. Insulators become conductors. There will be silicon belongs to semiconductor family. At a certain temperature, it acts as insulator. But when silicon is converted to nanosilicon, it will be a perfect conductor. These are some examples for drastic changes when we convert a bulk material into a nanomaterial. Now, we have to discuss two important aspects which are the core part of this discussion, that is nanoscience and nanotechnology. In coming few slides, we are going to differentiate nanoscience from nanotechnology. First of all, nanoscience. Science is the study about something in more detail. So, nanoscience is the study of matter at the nanoscale. That is, we are studying more about the physico-chemical properties and everything about nanomaterials. It is the study of processes and manipulation of materials at atomic or molecular scale. Atomic or molecular scale is less than nanometer size. Whenever atoms and molecules simply assembled together, definitely we will get a nanomaterial. And nanoscience deals with such an assembly, such kind of nanomaterials. Now, nanoscience is definitely an interdisciplinary branch because this nanoscience includes concepts of multiple branches or disciplines like chemistry, physics, biology, etc. That is, nanoscience has huge connection, important connection with other branches also. Hence, we can consider nanoscience as an interdisciplinary branch of science. Now, the question arises, what is nanotechnology? How it is different from nanoscience? We know that we are commonly using two terms, science and technology. What is the difference between science and technology? Science is the detailed study of something, some matters, some phenomena occurring in nature, etc. Science is the study and technology is its application. So, technology is the application of science. Now, what is nanotechnology? Absolutely, the definition is clear. It is the application of nanoscience. We can enter into details of nanotechnology. It is a field of applied science and technology. The main feature of nanotechnology is control of matter on a nanoscale, and of course, we can arrive at the final statement, that is, nanotechnology is a technology based on size. So, nanotechnology is the application of nanoscience. In nanoscience, we are studying the properties of nanomaterials, and in nanotechnology, we are using that science for different applications. So, technology deals with the applications of science. Now, nanotechnology completely involves, this is the core definition of nanotechnology. Nanotechnology involves the design, production and characterization of various nanostructures, nano devices and nanosystems by controlling shape and size for application in various fields. This is the most important part of the definition. We are constructing different nanosystems and nanostructures, and the ultimate aim is to apply in various fields. For example, we can take nanosystems, nanoparticles, and it can be used for sensoric applications, for applications in sensors, for application in the detection of toxic components, toxic metal ions, explosives. We can use nanomaterials for applications in medicinal field, for imaging purpose, for therapy, for cancer therapy. So many applications are there. So, in nanoscience, we are constructing the particles, we are studying their properties, and in nanotechnology, we are applying that properties for several certain fixed applications. That is the difference between nanoscience and nanotechnology. Now, we are discussing historical revolution of nanotechnology. Before entering into the detailed aspects of the nanoscience and nanotechnology and nanomaterial science, we have to begin from the historical part, and we are now focusing on historical revolution of nanotechnology. The history of nanotechnology has close connection with the contribution from Richard Feynman. The credit of inspiring nanotechnology goes to eminent physicist, Nobel Prize winner, Richard Feynman. And Richard Feynman won the Nobel Prize in the year 1965 for his work in physics, and his area is fundamental work in quantum electrodynamics. And Richard Feynman was a Nobel Prize winner, and he got the credit of inspiring nanotechnology. And Richard Feynman suggested that there is a chance to build machines. For what purpose? These machines can be used to manufacture objects with atomic precision. That is, Feynman suggested the machines, and that machines can be used to prepare very small particles. Moreover, in one of his world famous talk, there is plenty of rooms at the bottom, and this talk was given at Caltech on December 29th of 1959, and actually this talk laid a foundation stone to nanotechnology. We can elaborate this statement. There is plenty of room at the bottom. What is the ultimate meaning of this statement? There is plenty of room at the bottom. Plenty of room at the bottom means at nano level, at a small level. Whenever we are entering from top to bottom, that is from bulk material to scale down to nano, small level, there is enormous possibilities. The room means the possibilities. For a scientist, the room is his laboratory, where innovations are going on, where innovations and several research works are performing there. So, Feynman suggested this statement to scientists, to a team of scientists, and Feynman implies that whenever we scale down a bulk material and entering into bottom, that means entering into atomic or nano level, there is enormous possibilities to be unexplored. Enormous properties are there. That is, whenever we transform from a bigger material to a nanomaterial, there will be new properties, new phenomena, new physicochemical properties, etc. This statement is very important, and this is actually considered as the foundation stone to nanotechnology. In the year of 1988, Richard Feynman, the light is out. Nanotechnology. Actually, the term nanotechnology was introduced in 1986, and the term nanotechnology was first used by, in its real sense, first used by K. Eric Drexler. He wrote a famous textbook. That textbook is shown here. It is Engines of Creation. In his famous textbook, Engines of Creation, K. Eric Drexler used the term nanotechnology as at its real sense as we use today by K. Eric Drexler. So, now we have to discuss some other historical significance also, historical parts of the nanotechnology also, out of which we have to give some focus on Faraday's divided metal. Faraday's divided metal, you heard this term somewhere else, and Faraday's divided metal represents ruby colored colloidal gold. you are familiar with the colloidal particles. What are colloids? Colloids also have the dimension of nanoparticles, that is, they have a nanoscale dimension in the range of 100 nanometer. So, colloidal gold simply means it consists of nano gold or gold nanoparticles. Faraday prepared a solution that is named later as divided metal, and Faraday's divided metal is shown here. In the picture, it is clear that this ruby colored liquid is nothing but gold. He prepared it by some chemical reactions, and he arrived at the conclusion that it is nothing but consists of very small particles of gold. That is, gold nanoparticles or small particles are obtained by dividing the bulk metal. Hence, Faraday himself called it as divided metal. Now, the preparation of Faraday divided metal is performed like this. Sodium tetrachloroaurate, that is NaCl4. Here gold, sodium is in plus 1 state, chlorine is in minus 1 state. Absolutely gold is present in plus 3 oxidation state. So, gold plus 3, it is a salt of Au3 plus, and Au3 plus is present in sodium tetrachloroaurate. He made it into a solution. It is an yellow colored solution. It is then treated with a reducing agent or reducing solution, and that reducing agent is a phosphorus in carbon disulfide. So, Faraday took a solution of NaCl4 and mixed with the carbon disulfide, and he observed a color change during the reaction. The yellow color changed to ruby red. That ruby red solution is known as divided metal. Faraday concluded that the ruby fluid is very finely divided metallic gold. At the time of Michael Faraday, there is no term nano or nanotechnology or nanomaterial science, but Faraday is very strong in his belief that he believed that these particles are obtained by dividing the bulk of gold, dividing the gold. So, he called the solution as divided metal or divided metallic gold. Now, another important aspect, another important material associated with the history of nanotechnology, that is nothing but Lycurgus cup. The Lycurgus cup is one Roman vessel, Roman glass vessel, or it is made up of glass. And this cup represents the outstanding achievements of ancient glass industry in 4th century. This is the picture of the cup. This is Lycurgus cup, and the decorations, you can see some decorations on the surface of the glass, and these kind of decorations shown here represents actions of King Lycurgus, depicts the legend King Lycurgus, hence the name Lycurgus cup. And this glass is not a simple glass, it is made up of dichroic glass. Dichroism means it may shows different color at different light. The color of transmitted light is different from color at reflected light, etc. We can enter into more details of the Lycurgus cup. And the dichroic effect, the different colors, the glass shows different colors, and that dichroism, the dichroic effect is achieved by gold and silver nanoparticles. It is happened in 4th century. Later on, analysis of the composition of the Lycurgus cup, we made the conclusion that it consists of nano gold as well as nano silver. Now, what is the peculiarity? What is the peculiar color associated with the Lycurgus cup? The cup, the glass cup, appears to be green in reflected light. Reflected light means we are reflecting this glass with some source of light. That is, the light source is placed outside the glass. So, in reflected light, the cup appears to be green like this. However, whenever we are placing that light inside the cup, the light will be transmitted. So, the transmitted color is different. The transmitted color is ruby red. Transmitted color means the light source is placed inside the cup. So, transmitted light color is ruby red and reflected light color is green. That means the cup shows two different colors at two different lights. This is called dichroism. This effect is called dichroic effect, and it is very well clear that this dichroism is due to the presence of gold and silver nanoparticles. We can move on to the composition of this Lysergus cup in coming slides. And the color difference is due to dichroism. The dichroism is due to the presence of, as I mentioned, nano gold and nano silver, and the composition of nano gold is nearly 40 parts per million, and composition of nano silver is 300 parts per million. So, this Lysergus cup shows dichroism, different colors at different light sources, and dichroism is attributed to the presence of nano gold and nano silver. This is the most important conclusion associated with the Lysergus cup. We can enter into the compositions and this color etc. in more detail. Now, let us go through a short video clip associated with Lysergus cup. Now, we are discussing the actual composition of the Lysergus cup. For comparison, I put the composition of the modern glass and Lysergus cup glass. The constituents are on left hand side. Silicon dioxide, it is a major component. In Lysergus cup glass, it is 73%. In modern, our common glass, it is about 70%. Sodium oxide composition is 14% and 15%. Calcium oxide composition is 7 in Lysergus cup, and in modern glass it is 10%. From this chart it is very well clear that the major composition, the composition of major components, silica, sodium oxide, lime or calcium oxide etc. are more or less same in Lysergus cup and in common or modern glass. Then how this difference in properties? And the difference in properties is mainly in the form of dichroism, and dichroism is due to the presence of that gold and silver nanoparticles. That all about the discussion on Lysergus cup. Now we can enter into another area, another historical aspect of nanotechnology, another thing in the history of nanotechnology, that is stained glass. You somewhere seen in churches and then monumentary buildings etc. this kind of glasses with so many decoration colors etc. And the stained glass artists were early adopters of nanotechnology, and these artists, they don't know the actual composition of the glass they are using, what are the materials they are using, actual components present for generating the color. Such concept they don't bother, because they were not aware of the chemistry behind this, the chemistry behind the composition. But actually, on analyzing this stained glass used by ancient glass artists, it is clear that they consist of nanoparticles of gold, silver etc. That is, the ruby red color of stained glass is definitely from gold nanoparticles, and deep yellow color is produced by silver nanoparticles. And moreover, there is an important thing associated with the color, the size of the metal nanoparticles, either silver, gold, platinum etc. whatever it may be. The size of the metal nanoparticle difference can produce different colors. That is, as the size of the metal nanoparticle changes, there do a variation in their color. that is size dependent color. That phenomena we can discuss more detail whenever we are studying metal nanoparticles. There is a phenomena called the surface plasmon resonance, etc., that we will study in coming modules. So, stained glass artist used different sized gold nanoparticles as well as silver nanoparticles and other metal nanoparticles for producing beautiful colors, for imparting beautiful colors to the stained glass, even though they do not know about nanoparticles or the composition at that time. Now, medicinal preparations with the nano gold. This is also closely related to the history of the nanoscience and nanotechnology. Use of gold in medicinal preparation is not a new thing. You heard about the various Ayurveda medicines, etc. And so many Ayurveda medicines used nano gold as one of its component or small particles of gold as one of its component. Gold is used in many traditional Indian Ayurvedic medicines. We can move on to some examples. First of all, Saraswatarishtam. It is a medicine prescribed for memory enhancement. Next one is Swarnabhasma. It is a therapeutic agent. It is a medicine for several disorders, to treat several disorders such as rheumatoid arthritis, diabetes mellitus and nervous system disorders. So, we used nanoparticles during the historical time for the preparation of several kind of Ayurveda medicines. Now, Swarnabindu Prasana, SBP, is a medicinal preparation widely used in Ayurveda pediatrics as an immune booster. This is given to kids to to boost their immunity. The main ingredients Swarnaprashan, that is gold nanoparticle, cow ghee, honey, etc. So, this about the composition of SBP used as an immune booster in kids. The last part of the discussion, that is nanosystems in nature. Nature nanosystems. Every natural nanostructure is built up from substructures that are the nano-sized range. That is, we can take a nature system like a butterfly or simply a lotus flower, a lotus leaf or anything like that. We can take a nature system and we are going to analyze that component. On analysis, on careful analysis, we can see the presence of large number of nano-sized particles there. Now, we can take some examples for reference. That is, we can arrive at an ultimate conclusion that many natural systems are made up of nanomaterials. This we can prove by taking different examples from nature itself. First of all, we are taking the lotus leaf. The leaves of lotus flower is showing a phenomena, that is hydrophobicity. Hydrophobicity means the strong water repellent property. For example, if you are taking a lotus leaf and pour some water on the surface of that lotus leaf will never get wet because the water is totally drained from that lotus leaf surface. That water repellent property is due to the presence of some nanoparticles or some nanostructures present on the surface of the lotus leaf. How we can make sure the presence of the nanoparticles at the surface of the lotus leaf? This is made by imaging, and to see such nanoparticles we have to use some electron microscopic techniques like scanning electron microscopy, transmission electron microscopy, etc. to see the particles. For in a common way we can say that to see the small particles we are using a microscope, but the nanoparticles are even still smaller. You cannot see with the help of a common microscope. So, we are using specially devised instruments called electron microscopic devices like scanning electron microscopy, transmission electron microscopy, etc. This is the representation of the surface of lotus leaf with the help of a scanning electron microscopy, or this is the same image of a lotus leaf surface. And The SEM image in more detail is shown here. The SEM image or scanning electron microscopy image shows that the lotus leaf surface is covered with a micro-sized arrangement. That micro-sized arrangement is called papillae, and that papillae is decorated with nano-sized particles or protrusions. So, absolutely it is clear that the surface of the lotus leaf consists of so many nanostructures, and these nanostructures are responsible for the water repellent property. Now, this creature is very common to you. It is a gecko. Gecko can run on a dirty or a wet surface, maintaining full contact and adhesion onto it. And what is the reason for its strong adhesion property? This again attributed to the presence of nanomaterials. The gecko's amazing property lies in the nanostructures that are present on its feet. Gecko's feet are example for nanostructures in nature. This is about the same image of the gecko's feet. It consists of small arrangement called setae. The setae present in feet are made up of a protein called keratin. Keratin is a protein which is present in our hair also. So, each setae, that is a thread-like arrangement that is shown here. There are several setae in the toe of a gecko. Each setae further divided into nanostructures. That nanostructures are called spatulae. So, setae consists of spatulae. Several setae are present in the toes of gecko, and that setae are responsible for the strong adhesion property. In a simple way, the spatulae are responsible for that strong adhesion property. Now, you know about a shark. It can easily move through water without creating any disturbance or friction. Shark skin is a model from nature for a low drag surface. On analysis of the skin of the shark, we can arrive at the conclusion that its skin is also covered with big nanostructured arrangements, and that arrangements are called dermal denticles. This is clear from the same image shown here, and this presence, the presence of this dermal denticles cause the easy moving of that organism through water. Now, the very beautiful butterfly wings. The beautiful colors exhibited by the wings of the butterfly may be due to two sources: the common pigments or dyes and periodical nanostructures. So, even in butterfly, we can see the presence of periodical nanostructures, which has a strong contribution towards its color. Now, this is the SEM, scanning electron microscopic image of the butterfly wing. It is clear that the wings are made up of nano thin layers that cause light to reflect differently. So, the color of butterfly wing is definitely has a strong connection with the presence of periodical nanostructures present in its wings. Now, the thin films made up of nanoparticles produce rainbow color, different color, iridescent color when light strikes on this organism, that is our peacock. That is, peacock feather is very famous for its beautiful color, and that beautiful color is attributed to the presence of nanoparticles which are arranged in the form of thin film. This about the scanning electron micrograph image of that peacock feather. Spider silk is another nature nanosystem. Spider silk consists of nano-biodegradable threads. The most important peculiarity of that spider silk is that it is highly elastic. That is, it is elastic up to 10 times of its initial length. What is the meaning of this statement? We can take 1 meter spider silk. It is extendable. It can be stretched up to 10 meters. That is the peculiarity of this spider silk. On analysis of the electron micrograph, scanning electron micrograph images or SEM images, it is clear that there are so many nano-biodegradable threads. So, this much elasticity is a contribution from nanoparticles present in the spider silk. Now, we are going to wind up this section by giving some messages, that is importance of our branch, importance of nanotechnology. The multifarious applications of nanotechnology resides on remarkable features of nanomaterials. Remarkable features means the physico-chemical features, the physical properties as well as chemical properties. The physico-chemical features of nanomaterials are entirely different when compared to bulk material. This is one important aspect of nanomaterials, which made use these nanomaterials in nanotechnology. Nanotechnology is predicted to revolutionize every aspect of human life. It is definitely supplying medicines, the life care materials, so many things. The implication of nanotechnology in our daily life is very, very important. In coming modules, we can discuss more aspects about nanotechnology. Thus, by this module, we have discussed some introductory aspects about nanoscience and nanotechnology. That all about this module. Have a nice learning experience. Thank you.